Hello everyone. In this session, we are going to look at t-test. T-test is used to validate an hypothesis. Where do we use hypothesis testing? Let's take a step back. Hypothesis testing is used whenever we have to draw an inference about a population based on a sample performance. Just look at the image on your screen. Let's say I'm studying the average salary of people who are in this particular group. Instead of ascertaining the salary of each and every one and then computing the average, I just pick 4 people at random, ask their salary, and find out the average salary. I then infer the average salary of these 4 people will be representative of the group. So I'm drawing an inference about a population based on the performance of a small sample, right? I need to ensure that the sample I'm drawing is both representative and random. That is the requirement for a good sampling strategy. So if we have the hypothesis framed out and if we have the performance details analyzed, we can then decide whether to accept or reject an hypothesis. And one of the tests that we use for that is known as the t-test. There are 3 types of t-tests that can be done. One is the one sample t, where we are comparing between a group and a population, like the scenario I just explained, right? You are comparing the performance of a population and the performance of a group. So I use one sample t. And two sample test is used whenever I have to compare between two groups of people. I'm comparing the salary levels of group A and group B. So here I'm using two sample t. And here I call this as unpaired because the two groups are not related in any manner. If the two groups are related, as is the scenario here, I use what is known as two sample t, right? You can say that the performance of two groups after undergoing a particular course, after undergoing a particular training, after understanding a particular strategy, that will be an example of two sample t. Another example is you are considering the performance of a group of patients before taking a particular drug and after taking a particular drug. That also would come under two sample t paired. That is, the group is the same, but we analyze the performance of the group over a period of time. After undergoing a training, after completing a course, after taking a particular type of drug. Those are the scenarios that are applicable for paired t-test, right? So with that understanding, let's understand one sample t, two sample t in a bit more detail. We will see how to find, how to validate or reject an hypothesis using t-tests programmatically. Okay, so that's what we are going to see now. Let's first take a scenario where a company is trying its best to improve its sales. Okay, they are not able to meet the targets given by their stakeholders or the management. So they feel that the only way out is to introduce a new product. Okay, and after introducing the new product, their sales appear to increase. Now, can we use t-test here? Yes, of course, we can use t-test here, right? So before the new product introduction, the average sales of 25 people was 50. After the new product introduction, the average sales is 80, right? And if the standard deviation is 15, what is the t-score, right? As the new product improved the sales or not. So that's what we are going to see now, right? So what is the formula? The formula for one sample t-test is t equals m minus mu divided by s divided by square root of n, right? And s is the standard deviation here. Mean and mu are basically averages for the two scenarios, right? This is before the introduction and this is after the introduction. So we find the difference between the average and divided by standard error. S divided by, that is standard deviation divided by square root of n. N is the number of samples in consideration. This is known as a standard error, right? So the t is, we get a value of 10. This is the t statistic, right? So our aim is to validate or reject the hypothesis. What is the hypothesis, right? Let's write it here. The null hypothesis is new product introduction. I'm calling it as NPI, okay? The new product introduction, this is NPI, has not increased the sales, okay? Has not increased the sales. Alternate hypothesis, HA, is NPI has indeed increased the sales, right? HA is what we are trying to prove, okay? And the opposite of that is the alternate hypothesis, right? So we have computed the value of t statistic, okay? Now we need to compare this with the critical value found from the t distribution table, right? So this is the t distribution table, okay? For the alpha value of 0.05, which is the confidence level, right? Confidence level of 0.05, degrees of freedom. The sample size is n is 25, right? So degrees of freedom is n minus 1, 25 minus 1, which is 24. Where is 24 here? 24 is here. So what is the value from this table? It is 1.711. Since 10 is greater than 1.711, we reject H naught, okay? Which means HA is accepted, which means the new product introduction has indeed improved the sales. Okay, you understand it? Now let's see how to do these t-tests programmatically. I have considered Python and we are using Google Colab as the development environment. Let's start with one sample T. So the population mean is 27. I am comparing this number with the average of the sample. The sample contains 6 data points. The average of these 6 data points, how does it compare against the population mean? Okay, so let's draft the null and alternate hypothesis, right? Alternate hypothesis is what we are trying to prove, right? And the opposite of that is the null hypothesis. Null hypothesis says that the average, okay, let's call as mu A is equal to mu B, and this is, I'm calling the average of this is mu A, and this 27 I'm calling it as mu B, okay. Alternate hypothesis is mu A is not equal to, right, different from mu B. That's what we are trying to prove, right? And the opposite of that is null hypothesis. So you compute the t statistic and p-value. For that we will be using scientific Python, which is SciPy, and we will be using the stats package, okay? So when we execute this code, we get the t statistic is this and the p-value is this, okay? Remember I showed earlier, from this statistic I can look at the t distribution table and find the critical value for a particular confidence level, right? In this case, the confidence level alpha is 0.05, okay? And a certain degrees of freedom, right? In this case, degrees of freedom will be 5, right? Because there are 6 elements, which means 6 minus 1, 5, that will be the degrees of freedom. So 5 degrees of freedom corresponding to a confidence level of 0.05 is what I need to see. The value I get, I need to compare against the t statistic. That is one approach. The other approach is I can compute the p-value, which is what we have got here, and I compare against the 0.05. With the 0.05 corresponds to the confidence level that I have taken, right? So since p is greater than 0.05, we accept the null hypothesis, which means that the average are the same or nearly the same. The average of the sample that we have taken is the same as the number that we are considering, which is 27, okay? So if the p-value is less than 0.05, we would have rejected the null hypothesis, which means the average are different. Mu is the Greek notation for average, right? I'm sure you all would be knowing that. Clear? Is this clear? Now let's look at two sample t. We consider a case of unpaired. Okay. So here, we have to import NumPy pandas, and I also import another library, right? From stats models, we import the t-test underscore end. Okay. So these are the two arrays in question, and these are the two arrays that are being compared, right? These are the two arrays that are being compared. So what is the null hypothesis and what is the alternate hypothesis? Null hypothesis is the mean of data 1 is equal to mean of data 2, right? Alternate hypothesis, mean of data 1 is not equal to mean of data 2, right? That is your null and alternate hypothesis. So how do you go about it? First, you find the average and the variance. So this is the formula that you can use. But we have already got the t value and also the p value, right? So here p is greater than 0.05. That's what it is coming as, right? The execution of the code gives us the t value and the p value. So from this, I can directly infer that the null hypothesis has to be accepted because the p-value is greater than 0.05, right? So I have to accept the null hypothesis. Alternatively, that is non-programmatically, I can compute the t-value, use the degrees of freedom, okay, and the confidence level of 0.05, and use the t distribution table and get the critical value. So I can compare that value with this value, like I demonstrated in the earlier part of the video, right? So how will you compute the t-value here? I've got mean 1, mean 2, variance 1, variance 2. N1, N2 is known, right? So here it is 26.5 minus 28.5. The square root, of 9.1 divided by 6 plus 70.7 divided by 6, you will get 0.55, right? And that is the t-value we got programmatically also, right? So I can, as I said, I can compare this t-value with the critical value from the t distribution table, okay, corresponding to a confidence level of 0.05 and a degrees of freedom of how many entities are there? There are 6 data points are there, right? So the degrees of freedom will be 5. Degrees of freedom will be 5. So this is how I do manually and this is how I do programmatically. Clear? And now let's see sample t-test pair. Okay. If you see, for paired, we use scientific Python stats. For unpaired, we have to use this particular library, okay, stats models. So if I execute the set of codes, right, I get the t statistic and the p value. Very simple, right? So just a few lines of code and you have all the data in front of you. You can also use Excel, but I find that Python, using Python, you have more flexibility and it is quite faster. Okay.